Hello again, everyone, and welcome to this new session in our advanced track regarding our first Virtual X4 Developer Day. In this occasion, we are going to start talking about new possibilities for your digitalization strategy. X4 Suite goes Kubernetes. Well, my name is Luis, and I will be one of the two speakers regarding this session. And Carlos will continue with the presentation after some more slides after me. And of course, we have our three moderators that will answer your questions during our session. That will be Manuel, Jorge, and Elian. But before starting, let's take a look to some little remarks. This session will be recorded. Do you have any questions? Of course, but please use the questions and answer window. And please be kind and respectful to each other. So let's start. Now we are going to start speaking about Kubernetes, Amazon EKS, and of course X4 Suite, and how these three players can interact in the same place, giving us an abstraction and offering us an more easy way when making our deployments to preparing our production environments. First, let me start speaking about Kubernetes. What is Kubernetes? Well, we can define Kubernetes, for example, as an orchestrator that will take care about our deployment processes, abstracting us from the hardware. Okay, we'll only focus on the logical parts. Kubernetes is based on containers, in our case in Docker container, so which means that we can get directly all the benefits that containers has. For example, our applications, our pieces of software are packed in a container and are easily portable between multiple platforms. Imagine that you want today to deploy your application in a specific platform based on containers, and then tomorrow you need to deploy the same application in a different platform, container-based platform. You only need to get your piece of software packed in a container and deploy them. So in this way, it is very easy to work with Kubernetes. It gets us an easy overview when speaking about the deployments. Okay, what does it mean? It means that the DevOps road has new possibilities for us when speaking about Kubernetes and X4 Suite, which means that we can automate our deployment processes. That is a very good solution for our DevOps. Okay, we can make usage of tools like Helm, for example, to automate these deployments in the Kubernetes context. And well, for example, one of the another key benefits of using Kubernetes is, for example, automatic escalation based on rules. Imagine that we can define rules that specifies that we can scale up our application when the CPU consumption is up to 80%, for example, or when our application is consuming more than a specific threshold of memory. We can define this kind of rules and we can create automated deployment, automated escalations based on these resources parameters. So it's very interesting. But well, let's take a look to the architecture in a big picture, okay, without giving too much further details. But well, the main element when speaking about Kubernetes is the cluster. The cluster will be the element that will pack all the players that will be involved in this Kubernetes element. Okay, we can think about a cluster like if a company. Okay, because we are speaking about the company, we should have a boss, or yeah, maybe a boss is totally okay for our explanation. In this way, we can have here a master node that will be the responsible of managing all the resources inside our company, inside our cluster. How? Making usage from different tools that are inside this master node: API server, scheduler, control manager, and etcd. Okay, but what's the purpose of the boss in this context? We need some elements that do the work. Okay, we will have worker nodes. Worker nodes are, from the physical perspective, more nodes than master node, but with a different goal. Okay, the worker nodes, as the name says, they will be responsible that doing the work, and to reach the main goal of the cluster. Okay, what can we find inside a worker node? We can find different pods. Okay, what's a pod? Well, a pod is the minimal base of deployment inside a cluster, a Kubernetes cluster. Okay, but what does it mean? It means that we will have a file, a YAML file, where we are going to define our deployment. Okay, we will say, okay, I want to use some specific containers. In this pod, I'm interested only in have one container, but in this other pod, I will be interested in have 3 different containers. Imagine, for example, a real use case. Imagine that we could have, like in the third pod of the first worker node, we will have 3 containers. For example, one container that is running an X4 server instance, a second container that is running an PostgreSQL instance, and a third container that is running, for example, an Apache Kafka cluster. Why not? We could have this ecosystem running inside this pod, okay? And we could have inside the same worker node different pods with different purposes, okay? All of them are based in containers. Because of that, we need inside the worker node something that executes the container. That's the Docker layer that appears behind under the pods line. Okay, it will be the responsible of executing the containers. But it is enough to execute the containers? No, we need to ensure that these containers that are present in this worker node are being executed in the right way. That's the goal of the kubelet. Okay, the kubelet will ensure that every container is being executed in the right way. And because we have different worker nodes and may one or many master nodes, we need some kind of communication between all of elements inside the cluster. Kubel proxy is the responsible of doing that, enabling and building all the needed stuff behind that in order to ensure the communications. Okay. But okay, we have spoken about the cluster. We have spoken about the elements that appears inside a cluster, but how can we populate a cluster? How can we interact with a cluster? To do that, we have a command tool called kubectl. We can use this tool to interact with a cluster, maybe, for example, to creating new worker nodes, to performing new deployments, to modifying existing deployments, to creating or scheduling tasks, jobs, whatever. Okay, all of these things can be done by a command line tool called kubectl. Or if in any machine is installed a user interface, we can do that in the same way using the user interface. So this is a big picture regarding the Kubernetes architecture. Okay, but in our session, we will be focused on a cloud service that offers Kubernetes solution. It is the Amazon product that it is called Amazon EKS. Basically, Amazon EKS is based on Kubernetes. And the idea behind that is the same that if we are interacting with Kubernetes, but we are speaking with a cloud service that is ready to be used. We don't need to install anything from our side and that's all, nothing. Just start using Kubernetes in the cloud, offered by Amazon. Let's show you a high-level diagram. Okay. As another products offered by Amazon, we have the concept of availability zones. Okay. In this way, what will Amazon do will be to create as many zones as we need in different areas. Imagine that we are interested in create an Amazon EKS cluster available for Central Europe region. Okay. What will Amazon do will be, for example, to create 3 different subzones and to replicate the content of inside of each subzone to make them available in these 3 subzones. Okay. In this way, we will have zone 1, zone 2, and zone 3. Imagine Europe Central, zone 1, Europe Central, zone 2, and Europe Central, zone 3. In this way, we will have high availability. All of these nodes are based on EC2. Okay, EC2 is the elastic container service as well provided by Amazon. And all of these elements are offered by Amazon, packed inside a virtual private cloud that is very important because it ensures all of our stuff is securized inside a virtual private cloud network. So that's very important. And how can we communicate with an Amazon EKS cluster? In the same way that we do with Kubernetes itself, without taking care about Amazon. We will need some previous steps to pre-configure the kubectl client in order to let him know, hey, now you are not going to communicate directly to a Kubernetes. You are going to communicate Kubernetes, but inside Amazon EKS. It means 2 or 3 command lines to configure passing your credentials and so on. But once it is done, then the rest of the interactions are done in the same way than if we are working with Kubernetes, applying deployments, creating jobs, etc. Okay. And now let's speak to you about another important part inside an Amazon EKS ecosystem, the control panel. Okay. The control panel is the element, the VPC that groups all of the master nodes replications. Okay. And it is important to know because Amazon EKS creates 2 VPCs separated. The VPC that contains the master nodes, and in another part, another VPC that will contain all the worker nodes. Okay. The communication between these 2 different VPCs are done by ENI attachment. Okay. And imagine we want to communicate with purposes. For example, to manage the cluster, we will do using kubectl, as we explained in our last slide, through a network load balancer defined because we can define not only one and single master node, we can have multiple master nodes. In this way, we need a network load balancer to let the petition to be redirected. Okay. And once we have our ecosystem with our applications ready in the other VPC, we will be able to interact, to connect to our applications through a load balancer service. Okay, it is offered as well by Amazon, and we only need to tell Kubernetes, hey, I want to expose this port as a service, and it will be done. Okay. From this point, you only need to get the URL of the load balancer service and the corresponding port, creating the socket and to be used. In our case, for example, imagine that inside our worker nodes, we have an X4 server instance, okay? 1 or many as we need. And what we only need to interact is, for example, our X4 designer software, and to provide the X4 designer, the URL, the credentials, and the port. And that's all. Once we have that, we will be able to connect to the Amazon AKS cluster and consume the services that were exposed. Okay? So, well, once we have spoken about Kubernetes, once we have spoken about EKS and how EKS offers Kubernetes packed as a service ready in the cloud, and once we have spoken about some key components inside the EKS ecosystem, let's go through a live demo. And to do that, our colleague Carlos will continue on this presentation and will show you the next steps.
Thank you, Luis. I hope everybody can hear me and everybody can see me now. Hello, my name is Carlos, and thank you, Luis, for this amazing explanation about all the Kubernetes and AKS part. So right now, as Luis says, we are going to proceed with our live demo. We are going to present you a use case that will facilitate the knowledge and so how X4 goes to Kubernetes. So in this case, we will define a use case, let's see like that, where we will create a Kubernetes environment in AKS. We will create a cluster with nodes. In this case, we will create a cluster with nodes, and we are going to create, in this case, we use the Amazon EFS. That is not the only one service that Amazon provides for volumes, but in this case, we use the Amazon EFS to create a persistent volume to use in our X-Force instance, and we choose Amazon RDS as a data model. We can choose Aurora, but in this case, in order to be fast and so, we decide to use Amazon Lysel, the RDS service. So what we are going to do, after we have this environment, we are going to show you in the fast and easy way how to integrate X4 Suite into our Kubernetes environment. For this part, we are going to have like 4 steps. The first step is that we are going to create a job, and this job is will be in charge of fill our EFS volume with all the necessary files to be provided with all the config files and all the necessary configurations to in order to, when we raise our X4 Suite image, will be all the environment ready in order of volumes to run without any problem. And after that is also in charge of fill and create all our data model. After that job, this job will rise, will do this job, and will die. After that, we are going to create a pod with one x46.2 server image inside. So at this point, what we have? Okay, so at this point, we have a full operative X4 Suite 6.2 version that we can connect through the load balancer service with the designer, and we can create our projects, access to all the tools like X4 Control Center, data management, and so. And we have a full operative 6.2 X4 Suite. But what happened? That we are so smart and we create a brand new 6.31 version with a new web apps, amazing tools, and we need to improve because 6.2 get obsolete. So we need to migrate, we need to update to the 6.3. So in an easy way, we are going to migrate to and update to 6.31 with one step. We are creating a job and we are launching a job that is in charge of migrate all the config files, all the X4 DB repositories with all our projects, users, configuration files, and so to our volume that is persistent. He migrate all the files to that and is also in charge of migrate all the data model from 6.2 to 6.3 without losing any information from the clients or from our projects. After that, in this point, we only with one step is only change, modify the 6. The X4 version. We modify the X4 version image to 6.3.1, and we will launch a pod, in this case, one pod with the 6.3 image. In this point, we have a full operative migrated, updated with the new brand 6.3 version in our Kubernetes, in our cluster, environment. This 6.3, we will have all the config files updated, all the projects updated, and all the data model updated. Okay, we are good, we are up. But imagine that in this case, we have the client have something like our developer day. He have one day that he know his web app portal, for example, we will have an amazing traffic of people access to this. And in this case, we say, hey, one day we will need to scale, and this is one of the most amazing tools of Kubernetes. We will scale our deployment to many replicas we need, and all these replica we will share all the information in live that we have in our volume, all the config files, all the project, and we will share all the data model that we have already in our data model service. And in this point, you will have all the replica you need in order to make your application stable. If one of these pods have problem and runs down or goes down, Kubernetes AKS in this case will be in charge of balance all your pods in order to achieve the goal that you want. In this case, 3 pods, 11 pods, all the pods that you need. And you can connect and disconnect, and you can work in all of these pods using the same data that we are already configured to get persistent in all this. So that sounds so good, but how easy is that? How easy is that? In order of the DevOps or administration of one company. Okay, we will proceed to show you. In this case, we are using our EKS service that Amazon provides. In order to be fast in this presentation, we already have a cluster created, because a cluster takes like 15, 20 minutes to create. This is what Amazon takes to create a cluster. This is nothing to do with that. But in this case, we have the easy platform in Amazon using CloudFormation in order to create a cluster. It's easy. You only need to configure in which way you want the cluster, git next, 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 and Amazon AKS will create it for you. In this case, as I say, we already have a cluster created with all the networking, with all the node group, with 3 nodes, full operative in different availability zones, like Luis explained before, and so. So we have the cluster already created at this point. What we need the file system created. So in this case, it's the same. Amazon provides you. In this case, we use the file system, Elastic File System service to create it, and we already have one file system, created, but it's so easy. It's so easy because you configure, in this case, a new file system that give you a lot of advantage. Like, for example, they do automatic backups. And you can configure the life cycle, and you can configure the network access and a lot of things that you need in your environment to give all the information persistence. As I said, we already have one created. And okay, but where is our image? Where is X4 Suite image? So in this case, we were so smart and we get up to the Docker Hub repository, our image. So we have the 6.2 X4 suite image, and we have 6.3.1 image updated. So you can do you can in an easy way. You can take this image and use in your environment. In this case, we are going to use it to do it in Kubernetes. So let's go to the fun part. How we do all these things that I already told you. As Luis explained, the way that we have to connect with to AKS to our cluster is using kubectl tools. It's a command line that we use to give all the commands and tell the nodes and the pods how they need to deploy and how the service will rise and everything. So in this point, we have our cluster, our IDS data model, and our volume configured at separate system volume. So we will go to the first step, the initial one. So the initial one, we have a YAML here, which is in charge of configure all the files, as I explained before. All the files are all the necessary data from, as you see here, the data model. And so when we when we create the 6.2, we will rise with any problem. And it is so easy as if we apply this YAML, the initial one, we will run and it will create that one, and it will tell us that it is created. Okay, what happened right now? If we do a kubectl get all, we will get all the information of our node. So right now we have a job, the job that we launched, the initial setup that we create, that is still running. So right now, in this moment, he's doing all the things that are necessary to configure in our RDS and in our EFS volume all the data. It takes some seconds, and if we see again what is happening in there, it will show us that it right now is complete. So he finished his job and he died. After he died, as you see, the completion here was 0 to 1, and now is completion. The duration was only 11 seconds. 11 seconds. We will delete it in order to have more clear environment, because we will create more things here. So we will delete this job because this job is dead and he finished his job. So right now, what we are going to do, we are going to apply a YAML, which is the deployment in this part, the deployment, with one replica, in this case, just one replica, with a 6.3 container, with one container with a 6.3 source project image inside. And what more have this file? And let's give 1 second into this file. Besides that, this file have the environment variables that is to say, hey, watch out, you will be point to our Postgres data model RDS that we already have in Amazon RDS, and the volumes you will attach, you will link all these files to the file that we already exist, because in the first step we created in our volume, in our EFS volume. Okay, that's all, and the volume will be the EFS volume that we already created. So if we launch this, this deployment, here it is. Now we are communicating. Oh, sorry, yes. I miss a F. This is the nervous. My hands are shaking right now. It's normal. So right now, EKS told us, hey, this deployment is created. What happened with this deployment? Let me clean the console and let's see what happened in this deployment. Meanwhile, what we have now? We have a deployment X4 server, as you see here, the name X4 server, that will run one replica. It means one pod with the X4 server running inside. If we go to the logs of this pod, we will see that the X4 server is starting. Those are the logs of the X4 server when he starts running. And meanwhile he's starting, we are going to open a 6.2 designer. We open a 6.2 version designer because right now we are using 6.2. We get old. Right now, I appreciate to update to the 6.31. That will have a very amazing improvement. And as you see, it's normal, the normal time that a X4 server takes to run. And if we go to the designer, you see that in the managed connection, we have an X4 server Kubernetes connection that we have in the host. We have the URL that Amazon provide us with the load balancer service. The load balancer service, as Luis explained before, is the way that the client have to connect with the worker nodes. So load balancer service provides a URL and a port, and we can connect from the designer through this load balancer to the server. If we, as you see, we have the 6.2 successfully started server, and if we connect, we'll ask for the license. We put the license that we already have, and we buy the license. You will see that licenses give you access to all the adapters and so and all. And we are connected right now to our cluster using the S4 Designer client, and we can create here all the projects that we want. For example, we have the basic, the consumer. We are going to use, for example, the energy supply reports. As you see here in the server is getting updated. Meanwhile, we are connected here by kubectl to the logs of the server. You see, we can create, we can launch our applications. In this case, the web app application, this template about the energy report, admin demo. So it's full operative. As you see, we can also connect to the different tools. In this case, we are going to try if the data get persist after the migration. For this, we are going to create, for example, a user in X4 Control Center. If we create a new user, for example, we are going to call it X4 Live Demo with a password. I will not say to you, sorry. And the forename will be live and the demo. We create X4 new user. Okay, what we have right now, as I promised to you, we will have a full operative 6.2 instance in a pod running with the 6.2 image from the X4 suite, and we can connect through the designer and we can work there, we can create our projects and so. But what happened? We're getting old because we have the brand new 6.3 update. What we do, how we can update to a 6.3. Imagine that you are in the old way and you have 150 machine, 100 machine, and you need to migrate one by one, or you need to migrate in your servers by hand all the servers to a 6.3, launch the migration tool by hand, and manage all this mess by hand. No, in this case, we are using Kubernetes Sense God. And if you need me, we are going to go to the next step. Okay, right now, let's see how our node is working right now, what is in our node, and we will see that we have a pod, that we have the deployment. Okay, we are going to delete this deployment because it's the 6.2 or 1. Okay, we need to say one thing. In this moment, we don't have service. In this moment, we have a shutdown. shut down. Maybe in other case, do it by hand. We need 1 day or we need all the night to do the migration. And so in this case, according to our client, to our project, to how many nodes we have and how many projects we have, will take less or more, but it will be so fast. Why? Because in this case, we are going to run a job, which is the X4 migration job. What will do this job? Okay, this job is in charge of using a container with the image with the 6.3 X4 sheet, will call the migration tool automatically and will migrate all the config files, will migrate all the repositories, and after that, we'll copy and we'll fill our volume with all the migrated existing files, and we'll migrate all our data model. Okay, let's proceed in this case to launch the migration step. Okay, if we choose the X4 migration YAML, we will launch this job. And right now we tell to AKAs, hey, please launch this job. She say, hey, this job is created. Let's see what happened inside. If we get all again, sorry. If we get all again, what we have here, we have a job, X4 migration jobs that is running. It's not complete. It's not complete. It's not complete. It's running right now. So what happened is we see in the logs of this job. If we go to the logs of this job, we will see logs. Come on, Carlos, don't get nervous. If we go to the logs of this job, we will see the migration tool running. The migration tool that say that all the settings are going to be migrated from 6.2 to 6.3 version, and updating the SQL data model to 6.2 to 6.3, from 6.2, sorry, to 6.3 version. So right now at this point, let me clean here. Right now at this point, all the data, sorry again, all the data are migrated. So this job is complete right now. As you see, it's complete. He finished his job and he died. Nothing to do. Let's go to delete it in order to have more clean environment. What happened right now? We have all the data. We have all the data model environment migrated, but we don't have the 6.3. It's in an easy way. I will show you that you will have the 6.3 only modifying the version of the image that we provide for you here in our Docker Hub repository. Pointing the container image to the 6.3, in this case, we will have a full updated 6.3 environment. If we apply again, this YAML will do the same as the 6.2, but with the updated image. And this updated image will have a lot of amazing new improvement in web apps and in all different VPN and so. So what happened? Let's see what happened inside. What happened inside? Right now we have a new deployment, 6.2 deployment that is ready, that is up to date, and it is available 14 seconds ago with 1 node that is running, because we say here in the replica that we will only run one pod. And right now, if we go to the logs of this pod, we will see the logs of the brand new 6.3.1 X4 suite. Meanwhile, he's starting, we are going to use the designer 6.3.1. In the same way, we need to create a connection, and we need to point the server, the host of this connection, to the load service that Amazon AKAs provide to us to connect to the nodes. So as you see here in the 6.3, we have the same connection, and we have here the URL, we have the port and user and password and so. And as you see in the log, sorry. Yes, I have a problem, yes. And this is the problem of the direct. Sorry, this was my mistake. And you see a 6.2 because I forget to save, sorry, the YAML. And I change here the 6.31, but I don't save Control S. I don't save the YAML. So in this case, they deploy the same YAML that he have with the 6.2, but okay, there is no problem. You have this problem, okay? No worries. You delete again the deployment, the X4 server deployment, and we will rise 6.31 again, because right now I save it. What happened inside? He is right now, AKS is deleting the pod, is switch off the X4 server, deleting the pod. As you see right now, the status here was running, and right now is terminating, and he already delete the deployment. Once this pod is switched off, we will rise again this deployment, but right now, sorry for that, here it is, pointing to the 6.3.1. So let's do again. We rise again our deployment with one replica. And if we go to see what is happened inside, we will see that right now is running. So it's running. If we go to the log, we see that X4 server is running again. Even with my mistake, that I swear to you was not on purpose, even with my mistake, it was so easy. It was so fast get this confusion fixed, because only we delete the deployment and we rise again the deployment, pointing to the good image that we have. So once the server start, we will connect through the designer and we will see what happened in this case. So it's good to say, as I said before, that the load balancer provides us this URL and this port. We need to manage in the deployment. We point our deployment to the container port 8080 in order to connect, and we need to define in our S4 server, we need to define the user and the demo. So as you see, one thing that is good to mention, the license is already charged right here. We already have the license. So what happened? That the license, we put the license in our volume. So you don't need to put the license again in 6.3. So we have you keep the license, you don't lose the license file, and you don't lose the permission in 6.3. And in this case, as you see, we have the 6.3 started. We are going to connect through the designer, and as you see, there is no license, and we have the project that we already created in the 6.2 that we have totally updated to the 6.3.1. We can go into, in this case, of the web app. We can go inside. As you see, we can navigate, we can create a new one, but in order to be fast, I will not do all the things. You are able to create a new ESB project. Let's take this ESB tutorial. So you are able, as normal, at create a new one. And if we go to our tools, we can go to the control center, and let's see if the information, if our data model is migrated to the 6.3.1, but if our data still persistent. So in this case, we are going to check that the client that the user that we create is already there. And as you see here, we still have the user. So that tells us that all the data is still present, but in the 6.3.1 data model format. So right now we are here, but we say, okay, what we can do right now? We have our keynote, and we prevent that this day all the traffic will be in our application, and we need to raise more application of our X4 suite. We need to raise more pods with X4 suite in it in order to the servers and the load balancer manage all the balancer and don't go down and don't switch off the application in case, or don't go one pod, the only pod that you have right now, down in order because the X4 server cannot achieve all the manage and so. So in this case, there is two ways to do it. Easy ways. One way, we can modify our deployment that we already have, and we put in the replica all the replicas that we want to raise. 3, 5, 11, 100, all the replicas that you want. Or you can go, and we will do in this way, we can go through the command that Kubernetes provide is a command that is scale. So what we are going to scale, let me put you first in this part that we have right now. We have only one pod in our deployment. You will see only one pod that is running in our deployment 4 minutes ago. So we take the deployment and we say, hey, I want to scale my deployment to, for example, 3 replicas. What is doing right now Kubernetes? Okay, Kubernetes right now is scale, update, our deployment to run 2 more pods. The pod that we already 6 that was created 5 minutes ago, and 2 new pods. So in this case, we have 3 pods with 3 instances of X4 server 6.3.1 inside, and it will promise you it will manage all the data, all the connection, and so. And right now you can scale up and scale down again to 1 in order to the necessity. So in this case, imagine, and let's do this last scene, that one of these pod gets, TLS, one of these pods gets down. We are going to delete 1 pod. Yeah, okay, we don't care. But we are deleted by hand. Is the same scenario that 1 pod crashed and you have only 2 pods? What is doing inside right now Kubernetes during AKS? As you see, I can do nothing here. Right now, he's deleting this pod because I say to delete it, but all the tools inside of the node says, hey, what happened? You told me that we need to have 3 pods full operative, but one of them is down. We need to raise another one with all the same instruction that you define in the deployment, and it will run. And again, and I will balance to always be 3 or 5 or the number of replica that you define in your deployment. As you see right now, we go to kubectl get all, and what is happened there, that we have 3 pods. One is running 6 minutes ago, the other one is running that, and we have the new one that is created, but we always will have 3 pods. So in this case, what we achieve, what we have a full operative example and exist.3 replicas, 3 replicas, or in this deployment, 3 pods with exist.3 inside full operative connected to our volumes and our data model. So I hope you like it. I hope you enjoy it. And thank you, Luis, for the support in our presentation.